Hello, thank you for watching this video. So in this video, I'll be doing question 2 of May-June 2021 question paper, Mathematics paper 1. And question 2 have quadratic sequences. So I'll read the statement and then answer the questions that follow. So 2.1, consider the quadratic sequence that have these terms that I will write here. So you are told that, what is it? 72, 100, 120, 132, and so on, forms a quadratic sequence, right? So, you know, a quadratic sequence have the general equation Tn is called an squared plus bn plus c. So you're told that this is a quadratic sequence with this general nth term here. So 2.1.1 read as follows. Determine Tn, the nth term of the quadratic sequence. So they want you to find Tn, the nth term of the quadratic sequence. And you know that the nth term of the quadratic sequence is in this form. It should be in this form, right? So they want you to find A, B, and C of this quadratic sequence here. Okay, so what do you know about quadratic sequences? So first thing, they have this nth term, which is this. And then the second thing that you know is that they have the second constant difference, second common difference. So I'll write the terms. So you have 72, you have 100, you have 120, 132, so on. So now, if we find the difference between these two, between two consecutive terms, that's what we're going to do, right? Find the difference between two consecutive terms. We'll be doing that. So the first difference is an arithmetic sequence. So the first difference of this term forms an arithmetic sequence, right? So now when you find the difference between those arithmetic sequence terms, then now you will get a constant difference, which we know from arithmetic sequences. So now, when you have the differences here, and then you subtract two consecutive differences, now you will get a constant difference, which we call D in this case. We call that common difference D. Okay. So now, let's get moving. So I'm going to clean this, and clean this. So what do we say? So we say 100 minus 72. What do you get? You get 28, right? What do you say do next? 120 minus 100. You get 20. Say 132 minus so 132 minus 120. What do you get? You get that your answer is 12. So these terms of the first difference, they form an arithmetic sequence. And then now, the quadratic sequence have the second common difference. So now you find that second common difference by finding the difference between two consecutive terms of your arithmetic sequence, which is of your first difference. So now, we'll get this D, the constant difference D, by finding the difference between the two, or the difference between the two. So you say 28 minus 20 minus 28 is minus 8. Say 12 minus 20 is minus 8. So you have that your constant difference D is called minus 8. So this is your second constant difference D, which is called minus 8. So now, what we are asked to find, we are asked to find A, B, and C, right? So you know that 2A is equal to your D, right? Which means that 2A is equal to D, which is minus 8. So you divide by 2, you divide by 2. So this goes away, you're left with A. So this tells you that your A is equal to minus 4. So which is this guy here, is minus 4. So what do you do next? You say, okay, I'm going to substitute my minus 4 there. What do I have? I'll say Tn is equal to minus 4. Minus 4 n squared plus Bn plus C, right? We have our part. What do we need now? We need C and B. So what are you going to do? I'll say, okay, term 1, T1, I can find it by saying negative 4 times 1 all squared plus B times 1 plus C, right? Then I'll simplify this and say, okay, instead, I know what my, I'll say T1 is equal to minus 4 plus B plus C. And I know what my T1 is. My T1 is equal to 72. Put my 72 here. I stop here. Right? Do the same thing for the second term, T2. Say, okay, T2 would be equal to what? Minus 4 times 2 all squared. Right? Plus B times 2 plus C. Right? So when you simplify it, we'll say you have T2 is equal to 4 times, minus 4 times 4. That's minus 16 plus 2B plus C. So I know what my T2 is. My T2 is 100. So I have two equations. This equation and that equation. So you have these two equations. What you can do with them, you can solve those two equations simultaneously. Say, write T1 here. So you say T1 is equal to minus 4 plus B plus C, which is equal to what? 72. Then you find the difference between the two. So it's more like you're saying T2 minus T1, which is equal to you say minus 16 minus 4. So you have minus 16 plus 4, because it will be, so it will be 16. Okay, let me write it as it is. So you say 16 minus negative 4. So it will be minus 16 minus 4. So it will be minus 16 plus 4. The answer will be minus 12. Right? Then 2B minus B plus B, C minus C, that's 0, is equal to 100 minus 72. This is 28. So you solve for B. So your B is equal to 28 plus 12, which is equal to 40. You have your B. Then you're left with what? With C. You can find C from this equation or from that equation. It's up to you. But let's use this one. This one is much simpler. So minus 4 plus B. B is 40. Plus C is equal to 72. Right? So this and this, they make 36. Plus C is equal to 72. Then you transport the 36, so you have C to be equal to 72 minus 36, which is equal to 36. So you have your C, you have your B, and you have your A somewhere here. So the Tn that they were looking for, which is now the answer, I'm going to write it here. So the Tn that they were looking for is Tn is equal to, we said Tn is equal to, let me write this. So Tn is equal to an squared plus bn plus c. So your Tn now for this sequence is equal to minus 4, because your a is minus 4, n squared plus bn. What is your b? Your b is 40, which is plus 40n minus or plus 36. This is your Tn for this equation. And we have answered the question. So you have found the nth term, Tn of this equation, which is this. So we're done with 2.1. I'm going to clean the board and we'll go to 2.1.2. I hope this is clear. A term in a quadratic sequence, which is this sequence that we're given here, is equal to the 12th term of a sequence of the first differences. Determine the position of the 12th term of the quadratic sequence. So, you are told that a 12th term of the sequence. So, let me do this again. So, I said we have 72 here, we have 100, we have 120, we have 132. Right? So, we have this difference here, which I told you on the previous question that the first difference forms an arithmetic sequence. Right? Even the second one is an arithmetic sequence, but a constant arithmetic sequence. So this difference here forms the arithmetic sequence. So if you find the difference between the first two terms, which is term 1 minus, so term 2 minus term 1, we got that this was 28, right? And then we said term 3 minus term 2, right? We got the second term of our sequence to be what? To be 20. Then we said term 4 minus term 3, we find it to be 12. So this will continue going forward. So now, they are telling you that the 12th term of this sequence, so if it continues like this, so if this sequence continues like this, so this is term number 1, this is term number 2, this is term number 3. Let's say it continues. And then somewhere here, the 12th term of the sequence, let's say it's x for now. They're saying that this 12th term x is equal to one of the terms of the quadratic sequence that we're given. So now, which means if we continue this sequence going forward, we will find a term in the quadratic sequence that equals to that first difference, which is on the 12th position. So they want us to find what is this term and where is its position here. Will it be the first term, the second term, or the 19th term? That's what they want us to find. They're telling you that some term in the first difference equals to a term in the original quadratic sequence that we're given, but not necessarily these ones that we're given here. It might be term number 17. So they want you to find the value of that term, which is number 12, and locate it on the quadratic sequence, because we are told that this term here is equal to some term of the quadratic sequence. So you are told that your x is equal to Tn for some n is a natural number. So what they're telling you, they're saying find the value of that 12th term, and they're telling you that 12th term of the sequence formed by the first difference is equal to some term on the original quadratic sequence that we were given. So they are saying go and locate this term here on the quadratic sequence and see its position. That's what they are telling you. So now, the first thing to do is to find what the value of that x is. What is the value of the 12th term of this sequence? So there are many ways you can do this. The first one, you can use, you can say, okay, we have Tn is equal to a plus n minus 1 times d. This is the nth term for an arithmetic sequence. And then you can say Tn is equal to a, what is your a is 20, 28 is the first term here, plus n minus 1 times d, and your d was minus 8, which is this difference here, which we found on the previous question. So now, if you want the 12th term, you can say, okay, T12 is equal to 28 plus 12 minus 1 times minus 8. This will be the 12th term, that term there. So you find its answer and punch it. I don't want to make any mistakes. Minus 28 is minus 60. So this is minus 60. So that tells you that that term over there is minus 60. The term here in the 12th position is minus 60. So T12 of the first difference is minus 60. So now, also the other way you can do it, you can say, okay, when I got the first term, this first term I found it by separating the second term by the first term. The second term, you minus the third term by the second term. To find the third term, the fourth term by the third term, right? So the other way of finding what the value of what is, you must find, you can say, your 12th term, it will be T13 of this sequence, of the quadratic sequence, minus T12. Then you will be able to find it as minus 60 as well. But from this one, from this formula here, you will find it the same way you found the others. So substitute the 13 there and find the value, the answer of term number 13, and find term number 12 and find the difference. Then find the difference and find that it's minus 60. Okay. So what do we take from here? Now, we know that minus 60, we're told that minus 60 is equal to some term here in the quadratic sequence. So which means there is minus 60 on this quadratic sequence that we're given. So what we're left to do is to find the position of the minus 60, because that's what we were asked in the first place. Find the position of minus 60. But the first thing that we had to do, we had to find the value. We had to determine the value that was in the 12th position. Now that we know that the value that is in the 12th position is minus 60, is minus 60, then you can go and find where is our minus 60 on this equation, on this sequence that we are given. How do we do that? We use our general formula that we found. We have that the term there that we're looking for is 60. Then we want to find its position. So what do? We say, okay, we have Tn is equal to minus 4n squared plus 40n plus 36, right? So this minus 60 is equal to minus 4n squared plus 40n plus 36. So what do? Transpose the 60, or you transpose these guys to the side. You say we have 4n squared minus 40n minus 60, right, minus 36 is equal to 0. What do we have? We have that 4n squared minus 40n, this and this, minus 96 is equal to 0, right? So the next thing we do is to factorize this, or if you can't factorize it, use the quadratic equation. So I'll use the quadratic equation. So n is equal to negative b plus or minus b squared minus 4ac all over 2a. So I've taught how to use this on the previous questions. You can find my question 1 videos, then you'll know how to use this if you're not sure. So n is equal to negative b. What is our b? It's minus 40 plus or minus square root minus 40 all squared minus 4a. What is our a? Our a is 4. Our c is minus 96, all divided by 2a. What is our a? Our a is 4. So n is equal to, or n is equal to, so we get two n values. Then you punch that in our calculator. Negative 40 plus square root of negative 40 squared minus 4 into 4 times minus 96, all divided by 2 times 4. Get that the answer is 12, or the second one is minus 2. So we'll take this one here. So it turns out that minus 60 is also on the 12th position, even on the original sequence. So that will be that. So we move to the next question. Okay. So now we're done with 2.1.2. We'll be doing 2.1.3. 2.1.3 reads as follows. Determine the maximum value of the quadratic sequence. Determine the maximum value of the quadratic sequence. So what they wanted to do, they wanted to find the biggest value of this sequence here. Right? So, you know this is a quadratic sequence. So a quadratic sequence behaves in a similar manner as the quadratic function, which is the parabola. So, and this quadratic sequence is negative, right? So it will also preserve that negative or that concave down feature, right? Of the, as if it was a quadratic function or a parabola. So now, what do? You say, okay, I will use the same techniques that I use to find the maximum value of a parabola, because they behave exactly the same. So now, to do that, we say, okay, what I'll do, I'll find the position of the biggest value. Once I find the position of the biggest value, I'll find actual value. What is that biggest value? By substituting the position on the nth term that you have here. So what you do, you say, okay, n is equal to negative b over 2a, right? So negative b is 40 divided by 2a, which is a is minus 4, right? So what do you say? So you have minus 40 over minus 8. So the answer is 5. So you get that the biggest value is that n is equal to 5. So 1, 2, 3, 4, that is the next term on that sequence of hours. So you find T5, which is that the actual value by substituting your T5 here. So what do you say? Say T5 will be equal to minus 4 times 5 all squared plus 40 times 5 all times 5 plus 36. So the value of T5 will be what you are looking for, your maximum value of this sequence. So minus 4 times 5 all squared plus 40 times 5 plus 36. So you get that the T5 is called 136, and this is the biggest value of the sequence. This is the largest value of the sequence. We go to the next question. 2.1.4. 2.1.4. What does it say? 2.1.4 reads as follows. Determine the maximum value of the sequence. So we're given a sequence here. Minus 23 is 5, is 25, is 37, and then it continues. So they want you to find the maximum value of this sequence. They want you to find the maximum value of this sequence. So, the first step is to identify the sequence. What sequence is this? So first find the difference between these. So So this minus this, I think this is minus 28. Oh, so it's plus 28. Because it will be 5 minus 23, which is 5 plus 23, right? Then what do you have next? You have 25 minus 5. This is 20, right? And then what do you have? And then you have 37 minus 5. This is 12. So if you look at this first difference here, you'll quickly discover that these differences that we have here are the same differences we had on that sequence, right? These are exactly the same differences we had on that sequence, except that the numbers are a bit smaller. Yeah, they're a bit smaller than those. I'll say these numbers here are a fraction of these. If by how many, yeah, by what factor, I'm not sure. So you see, then by recognizing that these are exactly the same as those, it is clear that this sequence here resembles exactly the same features as that one. Yeah, so this sequence resembles that one. So that means also the fifth term of it will be the largest term of this sequence. So what do we have? We had minus 8 here, minus 8 here, and then, so what do we get here when we minus 8? We're left with 4, right? Then we add the 4, we get 41. So 41 should be our largest term, because this sequence resembles exactly that one. So if this one has its highest term at number 5, at position 5, this one will also have term at position number 5. 1, 2, 3, 4, 5. Then that's it. Go to the next one. 2.2. Consider the sequence. You're given a sequence here. Determine the values of x on the interval from 0 to 90, for which the sequence will be arithmetic. So I'll clean this and try to answer 2.2. Okay, so 2.2, consider the sequence, this one that you are given here, these 3 terms. Determine the values of x on the interval for which the sequence will be arithmetic. So they want you to find the values of x such that this sequence is arithmetic. So what do you know about arithmetic? Arithmetic sequence has the first difference, right? Which means if you have your minus 11 here and your 2 sine 3x here and 15 here, this minus this should be equal to this minus this. That's what you know about arithmetic sequence. The answers of these two should be equal, which means your 2 sine 3x minus 11 should be the same as 15 minus 2 sine 3x. Right? Then what do? Say, okay, now we want to find the values of x, right? Such that this is an arithmetic sequence and x is in this interval, that closed interval there. So transpose this to the side. Actually, let me simplify here. So we have 2 sine 3x plus 11 is equal to 15 minus 2 sine 3x. Then transpose this to the other side. We have 4 sine 3x is equal to 15 minus 11. So what do we have? We have 4 sine 3x is equal to 11 minus 15. What is that? 15 minus 11. That's 4. Then you divide by 4. You divide by 4. Right? Then you get that the sine 3x is equal to 1. So what you need to get now is the reference angle. So what do you say? You say reference angle is going to be arcsine 1, which is equal to 90 degrees. So what do you have? You have that 3x is equal to 90 degrees. How many marks? This thing is 4 marks plus K 360, right? Then what do? Divide by 3x by 3 by 3. Then you have that your what do you have? You have that x is equal to 90 divided by 3, that's 30, plus 360 divided by 3, that's k 120, right? You know that k is an integer. Then now, let's find a value, the values that will satisfy that condition, right? So what will that value be? So if our k is 0, then we have that x is equal to 30 degrees, right? Then if our k is 1, that means this thing is 150, it's above, it's not on that interval, right? Then if we get that our k is minus 1, it's negative, so it's also outside our interval. So our x should be 30. And we are there. I think we're done with this question. But let's test something and see if we really get an arithmetic sequence. So we say minus 11. So 2 times sine, 2 times sine 3 into 30, right? And 15. Minus 11. And then 2 times this is 90. Sine of 90 is 1, so we have 2 here. And then this is 15. This minus this, you get that answer is 13. This minus this, you get that answer is 13. So this is the correct term. And you're done with this question. I hope it's straightforward. I'll move to the next.